Hello everyone, welcome to our video solution to problem 1A from quiz 8. This is from my Math 250A class, that's Calculus 3 in the spring 2021 semester. In this problem we're introduced to a surface sigma, which is a parallelogram. So we parameterize the parallelogram with this vector function r of u v, and we restrict the domain of u and v to the interval 0 to 1. And in the problem, we assume that there's some sort of metal plate which is resting on top of this parallelogram, and the density function, rho, is given by the sum of the squares of the coordinates. We want to compute the mass of this metal plate by setting up a surface integral and then rewriting it as a double iterated integral. And we don't have to evaluate this integral, but at least we should set this thing up and get it ready to be evaluated. So if we want to compute the mass of a plate on a surface, we want to integrate the density function. So this will be a surface integral over sigma of the density function. Now this is a scalar function, so our differential is going to be ds. Now, we're going to want to rewrite this as a double iterated integral. So we need the parameterization for sigma, we need to evaluate rho on the surface, and then we're going to need to compute ds. So the nice thing is that sigma has already been given up here. So we're immediately going to be able to write this as an integral. U goes from 0 to 1, v goes from 0 to 1. Now we want to evaluate the density function rho on the surface sigma. So everywhere we see an x, right, here we have an x squared, we'll replace it by 2 plus u minus 4v, the y by negative 7 minus u plus v, and the z by 4 plus 2u. So we'll have 2 plus u minus 4v squared plus negative 7 minus u plus v quantity squared plus 4 plus 2u quantity squared. And we'll put some brackets around that. And then we're going to need ds. So remember the ds in this case will be the length of ru cross rv, and then dA, which we can write as, well, in this case we'll write it as dv du. All right, so we're going to have to do a little bit of work, compute the ru, the rv, take the cross product, and find the magnitude. So let's do that down below. So ru, let's see, we take a partial with respect to u, and in the first component we get a 1. In the second component we get a negative 1. And in the third component we get a 2. All right, how about rv? In the first component we get negative 4. In the second component we get a 1. And in the third component there are no v's, so we get a 0. Okay, so now we're going to take the cross product of ru with rv. And let's see, we cancel out the first column. We get negative 1 times 0 minus 2 times 1, so that'll be negative 2. Cross off the second column, go backward. We have 2 times negative 4 minus 1 times 0, so that's negative 8. Cross off the third column, we get 1 times 1 minus negative 1 times negative 4, so that's 1 minus 4, which is negative 3. Excellent. Now, we're going to take the magnitude. So this will be the square root of negative 2 squared, which is 4, plus negative 8 squared, which is 64, plus negative 3 squared, which is 9. Let's see, 64 and 9 is 73, plus 4 is 77. So the magnitude is root 77, and so we get here root 77 dv du. And of course, remember, we put that in this order because we want to line it up with that. All right. Now, the problem tells us not to evaluate it, and that feels good, not having to evaluate it. It's not going to be particularly hard, just a little bit cumbersome. We'll probably want to distribute a bunch of these things, combine like terms, and then it'll be a very straightforward, but just, lots of bookkeeping to do here. This root 77, that feels pretty good. We can pull that out, but yeah, we don't want to do it, and it doesn't make us do it. All right, we'll see you in the next video where we look at problem 1b, where we get to replace the scalar function rho, the density function, with a vector field f.